The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Your host here, Eric Kavanagh. And folks, I'm very excited to have a couple cloud experts on the show today. We're going to dive into what's possible in the world of cloud computing and really what's the future of work. And as I like to joke, what's the present of work? Yeah, the future of work sounds great, but how about right now? And the fact is, tremendous changes have come to the world of work. As we know, COVID had a big impact on all that, obviously, but lots of people were already working from home. It's not really the newest thing. I've been working out of my house since 1995. I want to say, no, 97. It was a long time ago when I first started working out of my house, and it was fantastic. But these days with cloud computing, you can log in from anywhere. You could do almost anything. One of the things that we learned during this whole COVID pandemic is that lots of the jobs that people thought could not be done remotely, turns out they could be done remotely. So that's a big change. And it's great for people who can do that. It's a difficult lifestyle to acclimate to if you have a certain personality. You do have to obviously drive yourself. You have to, no pun intended, as opposed to driving to work, but you have to kind of stay on top of things and make sure that you separate your personal life from your work life. That gets easier as time goes by. And the bottom line is productivity tends to go up. Now, there's some cases where that's not the case, in which case, obviously, you want to take a different approach. But working from home is a regular thing these days, and the cloud is a tremendous enabler on all sorts of levels. So let's first of all bring in our first guest, Michael Gibbs. He is from Go Cloud Careers, and he's got quite a career himself. Michael, welcome to Inside Analysis. Tell us a bit about yourself and what you're working on these days.
Thank you so much, Eric. It's an honor to be here. My name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers. And what we do is build high-performance cloud computing and networking careers. And like you, I've been working at home since approximately 2000. Now, I was an architect, a network architect, an enterprise architect, a cloud architect. So for me, it was which airport could I fly to and which video conference terminal could I go to, because I was always meeting clients. But the world has changed. The world has seen with the enabling technology of networking and the cloud, it doesn't matter where you're at. For the most part, you can be anywhere in the world and still service your clients and have a fantastic career.
Yeah, that's right. So you work on projects that help people become cloud architects. And you were joking before the show that the cloud is still pretty much the same in some fundamental ways today as it was 25, 30 years ago. But tell us, how do you help people? What is a cloud architect in your mind?
So, Eric, it's great you bring up that question, because the cloud architect is probably the most confused role in the world. So I train cloud architects, and here's what a cloud architect is. It's someone that knows how to transform a business through the use of information technology, most notably cloud technology. So doing architecture work or management consulting, it's really one of the same. I start with the CEO of a business and I ask them about their business goals, their business challenges, their pain points, the things they're trying to achieve, the things their competitors are doing. And then I think about, how can I make that business better? How can I increase revenue? How can I make the employees more productive? How can I decrease expenses? And then I find the technologies that'll do that. And obviously I show the customer the value by an ROI model to show them that the value of the solution is much greater than the cost. And after that solution is designed, I go out there and I leave and I design another customer's environment, and a team of engineers go and build that solution. So I have a global training company, and we train people to become cloud architects every day. Our graduates get hired. And the reason I was detailed upon what it is for some reason, people have engineering and architecture careers so confused. Engineers are the ones that are doing the building. Engineers are the ones doing the coding. Engineers are the ones doing the configuring. Engineers are doing the ones that are maintenance. And being the CEO of this organization, before we started it, we interviewed thousands of certified people to see if we could hire them, to see if they were good. And what we found is they knew the name of a service and how to configure it, but they didn't know what it was, how it worked, how to design it, the impact it had on the business. It was almost as if you were like trying to teach a doctor to say, here's 3 pills you can prescribe. Here's the dosage of these pills. We're not going to teach you how to diagnose. We're not going to teach you about patients' conditions, but here's your pills. and here's how to prescribe them. So that's honestly what most certification training is doing. And that's why we felt we had no choice to take the people that were certified or not certified and then teach them how to become architects, to actually do the architect job. And our students get hired every day because of it.
Oh, that's great. Yeah, I know that in our day job, in my day job, we focus heavily on data and data management. And information architect is a role that's been around for a long, long time. And there are lots of component parts that come together for someone who is an information architect, but it's all about the flow of data, where to persist data, how to get it where it needs to be. Lots of very serious, pressing questions that, of course, today, in today's world, with the amount of information out there, it's a pretty serious job to know what is the best path, what is the path of least resistance, if you will, what is the optimal way to design these environments, because there are so many options. But I guess in the cloud world these days, you've got a handful of big vendors that are now the mainstays. Of course, Amazon Web Services, Microsoft Azure, Google Cloud Platform. There are others, Rackspace, SAP, IBM. There are all sorts of other smaller ways to do these things. But the three seem to be the big three. I think that's probably not going to change too much. I mean, Roku is another big one, right? Or Heroku, that's what I'm thinking of. What do you say about the different options? Because I know you never go with a single point of failure, right? Talk about that.
So, Eric, for us, it hasn't changed that much. And here's the reason. A single cloud is a single point of failure, no matter what the cloud provider tells you. And here's the reason why. The cloud shares a single network. And if the network were to go down, guess what? The entire cloud goes down. The cloud has something called the control plane, which is what does the orchestration, where your virtual machines are, where your storage moves. And if that goes down, either due to an outage or a hack, again, the entire cloud goes down. And then we find ourselves with the third thing that can happen, which is a hacking event of the cloud. And if the cloud were to get hacked, that can take the cloud again. Now, generally speaking, despite recent press releases, it's not common to have a power failure in a data center, for example, that would take out down half of the world, because typically speaking, data centers have multiple power sources, generators, backup generators, batteries. But anytime you're in a single cloud, you have a single point of failure. So Eric, years ago, I was designing networks, and we would never use an AT&T, and we would never use two links from AT&T. It was always be AT&T or Verizon, or NTT and CenturyLink. And the reason is we could, if we had two links on AT&T and they had a cable cut, that'd be fine. We'd have a backup link. But if the AT&T network went down, we'd lose both links. And the cloud providers are telling people, here, you can just use multiple data centers in our same thing and you're available. But Azure had a big outage this year. Google had a big outage this year. AWS had numerous outages, and none of them were able to maintain 99.99% availability, which isn't even high availability. For example, a hospital needs 99.99% availability. An emergency dispatch center needs 99.99% availability. A bank does, where seconds mean millions of dollars. Imagine patients' medical records being on a single cloud, and the cloud has a power failure and it takes down the entire cloud. Patients will die. Doctors won't have the information on their patients. Nurses won't have the information on it. So we don't ever design around a single cloud. We always design around multiple clouds. And because of that, we use industry standard solutions. We don't use any of the main solutions from a cloud provider. Like a cloud provider like Amazon, for example, has a DynamoDB, which is a great NoSQL database. And they've got an Amazon Aurora, which is a great relational database. Google has their Cloud Bigtable, for example, which is the same. Microsoft has their own. We don't use any of those. If we need a NoSQL database, we use Apache Cassandra or MongoDB, because we can use that on any cloud. If we need a relational database, we would use a MySQL, a Postgres, and Oracle. Again, things that reside on every cloud. So pretty much we remove all the main cloud services, those proprietary things that lock a vendor and their data to be in a certain place. And we move it to something that works across multiple clouds, because that's how we make our customers resilient and have them really give them the best access to the best performance, the best availability. So that's why we always go multi-cloud.
So there's a term in the information world of reference architecture. And are you essentially creating a reference architecture for your clients such that, again, it can plug and play in any cloud environment? Is that kind of what you're doing?
Well, yes and no. So we have to be really careful as architects. We can do it engineering style, which is everybody gets the same design. You've got a cookie cutter design for the A bank, a cookie cutter design for something in the media, a cookie cutter design. And for that, for most cases, that's good. But remember, our whole goal is to transform a business. So one business's goal may be completely different from another business's goal. So really what drives our architecture is, what is that executive telling you? What are those business goals, their pain points, their challenges? what's unique to their organization, what's their special sauce, what's their workflow. So that drives my architectures. It's always about bumping up the business. It's never about the technology. The way a carpenter uses a hammer, I use cloud and network and data center technologies to help solve my customers' problems, but the tech is not what I work with. I'm solving problems. That's what architects do.
No, that's interesting. Well, and there are so many ways you can solve challenges these days. And, obviously cloud is the new center of gravity, I would have to say. I mean, on-prem, however, there's going to be a tremendously long tail to these on-prem environments. So when you work with customers, do you often have an on-prem environment that is the sort of control plane or the master plane that then dips into clouds as it needs to, or how does that work?
Well, it's both. So I work with a lot of organizations to build their own clouds, whether it be a Nutanix cloud or an OpenStack cloud. And that way they get the cloud agility, the auto scaling in their data center. And then I connect them to two clouds and they don't have that single point of failure. Now we have to be really careful about getting rid of the data center for the following reasons. We're never going to get to the performance in the cloud that we have in the data center by the nature of the way the cloud works. Cloud uses block storage. Block storage is slow. A provision IOPS volume on AWS is 64,000 IOPS at its best, and their newest, fastest gets us to 250,000 IOPS. Now, if we were to go to Best Buy and buy a Samsung 980 Pro NVMe drive, we're going to get 1 million ups for less than $100 versus an extraordinary cost per month. So we're in the data center, we can stripe a bunch of these NVMe drives together and really deliver blazing performance that can be 10 times better than the cloud. So for certain applications, I never take them out of the data center because, the new trend is data center to edge to cloud. And the point is, if we leave our super fast data center and we go to the way to the cloud that's 1,000 miles away, if we've got something closer to it, it'll perform more like our data center than the cloud. Here's the thing, if we don't get rid of the data center, we have the best performance. We can run the highest performance storage in the world. We can run the best networking. We can peer to 10 different internet service providers and have the best internet performance. We can control our things, and we have much more security we can do in our own data center than the cloud. I love the cloud. I advise the clients to go to the cloud constantly, but there's still a use case for the data center. Imagine a financial application that's doing algorithmic trading, where if you can make your trade 1 nanosecond faster than the rest, it could be billions of dollars a year in revenue. Now we move that to the cloud and we have 3 milliseconds of latency, and that's thousands of times more latency we have in the data center. So I use the data center, I use multiple clouds, but it's really about what problem am I trying to solve. So I don't think the data center is going to go away for many, many years. And I think there's good reasons to maintain the data centers and or turn them into private clouds like Nutanix, or as well as OpenStack, great clouds that can be used.
Yeah, private cloud. I mean, that is it's a fantastic way to leverage the power of cloud without kind of adopting some of the shortcomings, I guess. Is that about right?
Yeah. You get all the benefits. The only difference that you get in a public cloud versus a private cloud is we can do auto scaling and all those agility things. But in the public cloud, if I need a server, I can basically have an 8-year-old click 3 buttons and have it in 10 seconds. I could have the same 8-year-old click those same buttons in my data center, but if I run out of capacity in my data center, I have to call Dell, IBM, HP, Lenovo, or somebody to ship me a new server, which could take weeks. Where in the cloud, they've already bought the servers, so it's just instant. But other than that, it's the same. It's the same data center and network technology we worked with for 30 years.
Yeah, let's talk for the rest of the segment. Let's get into the edge, because a lot of people don't fully understand what that is. And the edge is basically any device that's out there in the world, like a cell phone can be an edge, a router in a shopping mall can be the edge, all sorts of monitors, cameras, different things like that. Everywhere can be the edge. And talk about opening up an interesting box of possibilities when now you have your data center, you have multi-cloud environment, and you have the edge. It raises a lot of questions about exactly how to do that and how to optimize. And I'm guessing that's something that you guys excel at, right?
Yeah, absolutely. For us, it's pretty simple because it's the data center. It's either a hosted data center at the edge or it's an Internet of Things devices, and they're all IP enabled. So we use the same networking that Cisco was doing for the last 30 years, or Juniper Networks was doing to do this. So for us, it's really, really simple. Where it becomes hard is in the cloud space. When I became a Cisco certified internet expert 20 some years ago, it was 75,000 pages of reading to pass that. And that was only routing and switching. And I recently wrote a book, and it's completely free on passing the Certified Solution Architect Professional, which is the king of all and queen of all cloud architecture exams, and we wrote it in 450 pages. So for us, from a networking background, from a data center background, this stuff is really easy. But if you did not have that deep networking background and you weren't used to building networks and points of presences and data centers everywhere and connecting them with high performance WANs at LAN type speeds, well, then it's all foreign and it's all scary. So it depends on what your background is. For we networking people, we've done it for 20, 30 years. None of it's changed.
That's interesting. That's a good point. You know, one of the cool things I learned exploring the edge was with Cisco routers, and someone at Cisco told me a while ago, I'm not sure how true this still is, but a lot of those early routers all had two processors on them, which is interesting. They built it for redundancy primarily. So if one craps out, the other one kicks into play. But then they figured out with Edge, hey, we can have the first processor focused on its usual job and use the second processor to do stuff for edge computing. Is that, have you leveraged that?
The way I set my devices to this is I'm a high availability person. So if I'm going to connect to the cloud, I'm going to have two high availability routers. Now, each module will have two brains or control modules in case one failed. I'll split my WAN links on 3 or 4 different WAN cards, which I'll bundle them together in something called the link aggregation group. And I'm going to use 2 separate power supplies. They're going to be plugged into 2 circuits. Now, of course, I'll have 2 of those routers, and I'll probably have another router that's running a VPN backup over 3 to 4 internet connections that we're load sharing via BGP. So for us, you know, it's all about heavy duty networking. Yes, you can use the processors on these things to do more, but in the military, in the tactical world, and in the high availability world, there's a motto: 1 is none, 2 is 1, and 3 is greater than 2. So I overbuild redundancy because, you know, 1 minute of downtime in a bank could be millions of dollars. Downtime in a hospital or a 911 dispatch center can mean people die. So what I do with all my customers is I evaluate the cost of downtime. And then from there, we determine exactly what to build in terms of availability.
One of my favorite quotes is by a futurist named William Gibson, which I love that because I live in a town called Gibbsonia, so I'm perfectly in tune there. And his great line, he said, "The future is here already. It's just not evenly distributed." And so we use that line for our TV show, just as it is, and then say yet, right? Because it's being distributed right now. And one of our guests coming up right now can tell us a bit about that. Steve Wallo with a company called Vcinity, that's vcinity.io, doing some really interesting things with data provisioning for the cloud. So Steve, tell us about yourself, your company, and what you folks are working on.
Sure, absolutely. Thanks, Eric. So Steve Wallo, I'm the CTO for Vcinity. It's funny that you mentioned the future is here, but it's not evenly distributed. In our world, the future is here, but it's not well known, right? It's something that in some cases people don't think is actually possible. So the company, it's been around for a little bit, but it created a paradigm breaker. And the paradigm has always been related to the fact that, you know, I have data that's being created everywhere, right? All around the world. But is the data where you need it to be in order to use it, right? And that's the trick. You know, Michael did a great job talking about multi-cloud and all these, you know, things. And that's a novel concept. It's something that we will definitely see provisioning forward. But there's one little missing component of it, and it's always been, do I have the data in the right spot, in the right cloud at the right time for me to actually do something with it from my business value, right? And the reason that we move things around, and this is really what the company's about, is that the age-old paradigm ever since the ENIAC, right? You know, something from many, many, many moons ago, was that in order for my compute, my users, my applications to have a good experience, I gotta have my data somewhere close. Right. And in a lot of cases, my data is not being created where that compute and application specifically, the cloud is created. So Vcinity came around, and what we did was we created a software solution that allows things to get glued together in a way that you can pick the compute of choice, pick it any cloud, doesn't matter to us. It could be prem, could be edge, doesn't matter. And point it to data and use it wherever it's created, even though it's globally distributed. And that's normally people at this point I say, we're going to make the WAN actually perform like a LAN. And that's where people's heads kind of turn a little bit. You know, we were talking about our dogs, and that's kind of the look I get, right? But it's really true. And it's one of those things where the future is here. It's not well known, but it is something that we've been pulling together. And, you know, it's a different way, it's a different model to use the cloud resources, to use the data center resources. As Michael said, you know, the data centers aren't going away. You know, there's a lot of power in that. But how do I link my data centers to my edges? How do I link my edges to other edges? How do I, link those back to the cloud in a way that I can use this federated approach in real time? And that's the trick, is that, I can move applications all around, but is my data there? Is it where it needs to be? And instead of making a copy and moving it, right? If I want to move it here, I'll move it over here. If I want to cache it over here, that's still just moving copies. We've kind of changed that paradigm. So that's what Vcinity does, kind of in a nutshell.
Yeah, well, this is very interesting. So you're probably familiar with Kubernetes or K8 as they show it online sometimes out of Google, which is basically distributed compute, right? But it's stateless and there's no data. It needs primary storage. It sounds like what you're doing is similar to that, but for the data side. Is that about right?
You're 100% spot on, right? We figured out how to move applications around with containers and everything else. There's a lot of orchestration and automation through that. It's fantastic leaps forward, 100%. The problem is you just still have this little puppy. You have this little data that has to follow it, right? And all of a sudden, my real-time means of, let's say you were talking about resiliency and failover and things like that. And I might be in one cloud, but if I want to have multi-cloud, I have data in two places. Well, if that needs to fail over to a different region, guess what happens? I have to have my data move to the next region, right? And did it get there in time? Is it all of it? Is it right? Is it stale? These kinds of things. And we've changed that, right? So that is a different approach. It's a different mindset in the way that you use the cloud. I think some of the stuff that Michael's doing with the cloud architects and designing these things can now take advantage of the fact that there's a new time element in getting insights because my data doesn't have to travel and transverse different pieces, right? One of the other things, and we actually haven't talked about this too much today, was we think about security, right? Let's say I want to use, we do a lot of media and entertainment and life sciences. And if you think about the media and entertainment guys, they're bringing, they're doing the next Marvel movie, the $1 billion movie. And the last thing they want is to have multiple copies of the data in multiple clouds. Or if I'm a user working at home, maybe I'm an editor sitting in Pune, India or something. Do I really want to send a portion of my movie to Pune, right? For this guy to have. The more copies I have, the larger my attack vector, right? So if I can change that paradigm, that's a plus from the security side as well. But the other piece is you really want this real-time mechanism. I want to be able to do things in real time from a business perspective to leverage stuff that Michael's put together. But I have to have access to that data in a kind of more modern approach, right? So that is a whole different way to think about what's happening. I want to be able to use the cloud, but I'm not keeping my data. Life sciences, for example, same thing, right? We work a lot with the people doing COVID research and electron microscopy and things like that. Great, fantastic stuff, but the data ain't leaving the building, right? But they need to leverage compute in a cloud or multiple clouds, right? I don't want to get vendor lock-in. And normally what would happen is you grab the data and you make a copy and you move it wherever it needs to be that you want to use compute. That fundamentally changes. So it's a different way to think about the way that your business can leverage resources outside of your organization, right? Without losing control and the integrity of my data, right? I want to keep it. I want to have people get to it, but not necessarily move entire data sets around.
Yeah. So you're creating a wide area network, a sort of de facto wide area network for data provisioning, essentially. And I'm looking at your site. It talks about how the file stays in one place. Is that WAN sort of a stepping stone or a conduit between the processing and the actual data where it lives? So is it almost like a real-time caching layer, or tell me about that?
Yeah, that's actually a really good question. So people always ask, okay, so you don't have to move the data, but you got to move something, right? So let's talk about what are we actually moving over the WAN? I think this will help answer your question, right? And let me go back and explain two things of what we've done. One is we've developed a mechanism, took it from the HPC world. It's memory-to-memory transfers, RDMA. Works great in the high-performance computing center. The problem is RDMA doesn't work very well at long distance. In fact, it doesn't work at all. We figured out how to solve that problem, right? It's something that's kind of unique to our company, a lot of patents around that. But what that enables is a very efficient, best way to do network stuff is memory to memory. We bypass a lot of the overhead and all the different stacks. And
interesting,
right? But the idea is that I want to be able to sustain that throughput over distance. This is one of the failures of a WAN. I can put 100 gig WAN out there, and I can fill up the port with 100 gigs worth of flows and all this stuff. The problem is you get a couple thousand miles away, it's starting to dribble out the other side. It can't sustain it, right? At least with the individual flows. So what we've created is a mechanism that allows us to say, hey, whatever you put into the WAN, whatever it is, 1 gig, 10 gig, 100 gig, doesn't matter, you're going to get essentially 95% of that, whatever you put into the gazintas, on the gazaltas, to use some very specific terms here, right? But it's the idea that I can sustain that throughput. Now, the reason I bring that up is, so how does that relate to me, using the WAN in a different way? Because here's what happens. If I can sustain that 95% or whatever it works out to be, that's essentially a LAN, right? I mean, if I can do that, that's a local area network, but I'm doing it at a global scale. So we've created this global LAN. And what that means is, from an application perspective, all right, so I have this LAN. Now let's talk about the data itself. So in real world, you guys know this, applications, let's say I have a terabyte of data somewhere, I don't bring the entire terabyte into memory. There are some cases where you do deep learning, some of the machine learning models, where I want everything in memory. But a lot of times you're only bringing in a little component of what you're asking for. Oh, maybe it's a drone footage. I don't care about the drone taking off. I don't care about landing. I'm interested in this particular part in the middle. That's all I'll move over. And we actually take those cues. So not only do we make it more efficient and sustainable over distance, but we're only moving the pieces that an application is asking for at any given time. So now what ends up happening is people say, okay, I get it. You're not moving the entire thing. You're moving just a little bit of data, and you're doing it in a new way. So what really happens here? How do you get around physics? That's what I always get. How do you get around physics? And we're not here to claim that we can beat physics. That would be insane. We'd hit the button and push them off the show, right? The little red chair that goes back. But the thing is, here's what happens is the application says, oh, I'd like this piece of the data from many, many thousands of miles away. We'll go grab that one chunk, turn it into this memory-to-memory sustainable thing, right? Squirt it over the WAN. But what happens is the application will always incur on the very first bit the latency of the link, 70 milliseconds, 100 milliseconds, whatever it is, right? But because of the fact that I can pressurize it, I can keep it at that 95%, right? Is that the second, the third bit, and the fourth, everything come right after the first at LAN speed. So we don't remove latency, we minimize the effects of it after the first bit. And what that means is, I got to wait an extra 70 milliseconds for my application to start. But once it gets going, as long as my latency doesn't pop up randomly all over the place, it feels like it's right beside me, the data and the compute. So that's what enables us to have these things where I can run applications in the cloud against data somewhere else and have it feel like it's right there.
Yeah. So basically, you're pulling data into the WAN and into memory, and then you're just kind of sliding it over in memory to whatever location is trying to compute the data. Is that right?
Well, we bring it to, so we have software on either end. So it's memory to memory between our software. But then what ends up happening is we want to make sure that, if I put a piece of software in, I want it to look like a storage device, or NFS, SMB, S3 object, doesn't matter. So the applications will get to us like they went to Best Buy. You mentioned we're having a device from Best Buy, right? We just look like a storage device that's sitting in the architecture somewhere. So we talk normal protocols to the applications, but in the middle, we do all that funny stuff that I talked about.
That's fascinating. That's very interesting.
It's different. And, to take on the whole multi-cloud thing and hybrid cloud, it's, to me, hybrid cloud is halfway there from an application perspective, 100%. Still the problem with the data, right? And multi-cloud is the same way. If I want to use multi-cloud, I want to use Azure and Amazon. I put data in Azure and I put data in Amazon. And I hope they're doing the right things at the right time and keeping it synced, right? That paradigm goes away. All of a sudden, because I'm not having to move my data to the cloud, I can say, look, I can run some applications in Azure, some applications in Google or Amazon or a private cloud, right? And have them all point back to a common data set. And if something changes or there's a disruption, we talked about a lot about resiliency, I can move to a different region. And because I don't have to have my data follow it, I can instantly recover from that. So it's a whole different way of creating an architecture that leverages cloud to complement what you're doing in your business on-prem or even at remote edges, things like that.
I love it. Well, folks, we'll talk to you next time.